easy chapter. You have done trigonometry in IGCSE, and it's quite close to that. So you have to give the date of today, give the heading, give the date of today, and give the heading trigonometry. This is our next chapter. So please put a date and try to make one single register for notes and keep the formulas and other working separate. I mean the solving the questions, whatever you do, so you can do it on a tablet or on a register, but try to make a separate register for notes, only notes.
Okay.
Okay, now we are this chapter trigonometry. This is the syllabus. They want people to revise sine rule, cosine rule, area of triangle, radian measure, use of arc length, area of sector, use of the formula S is equal to R theta, and then the sine, cosine function, their graphs, symmetries, and periodicity. So this is our third chapter in the course. There are total 5 chapters. The first one was algebra, second one was coordinate geometry, and the third one is trigonometry. Now, this is the list of chapters, list of topics, I'm sorry. Basic trigonometry, radian measure, and sketches including horizontal transformation. So after giving the heading, please copy the list of the topics in trigonometry.
Okay.
So these are the title: basic trigonometry, radian measure, including use of arc length. Why this list is necessary in A level? Actually, A level course is very diversified as compared to O level. Some topics are really challenging, like graphs, sketches are really challenging. Some topics are very simple, like sine rule, cosine rule. So the course is extremely diversified. So whenever you prepare for A level in any subject, the rule is very simple. You should know the syllabus well, and then you should have a habit of doing topical question. November has started, so November and December, 2 months. So you have to make a plan of doing topical, and then in the last 10 days, you can do full yearly. That will be the final practice. Normally, you can they just like 40 days should be for topical, 45 days, and 1 to 2 weeks should be for yearly. Achha, this chapter, we are starting trigonometry. We have made a list of trigonometry. Now I'm starting the trigonometry. As a rule, I will cover orally the GCSE work also. This is a good habit that some part is coming from IGCSE, some part is coming from original A level. I will be doing first the basic version. So let's put our first, acha, give the heading, simple trigonometry, the first title here.
Okay.
Now, I will be doing some oral revision here, and you can tell me whenever you want to copy something because you have done IGCSE, so the basic idea you already have. Okay, I'm putting the first concept, introduction. There are
Mm-hmm.
three, in a right angle triangle, there are three important ratios: sine theta, cos theta, and tan theta. Opposite, adjacent, and hypotenuse. Orally look at it. Can you recall them?
Yeah.
Good. So they are basically the three trigonometric ratios. Now I put an example. You just have to tell me orally what is sine ABC. Angle is at B. Acha, when angle is at B, my opposite would be 3,
Mm-hmm.
adjacent will be 4, and hypotenuse will be 5.
Mm-hmm.
So now, according to this order, can you tell me orally what would be sine ABC?
Um,
Sine is
so
opposite upon hypotenuse.
opposite over, yeah, opposite
So,
over hypotenuse.
hmm,
Opposite over hypotenuse.
so in number form here in this triangle,
So 3 divided by 5.
good. And cos,
And cos opposite, no, adjacent over hypotenuse.
okay, tan,
Opposite over adjacent.
good. Perfect. 3 upon 4. Acha, now the most common trick from IGCSE, I have switched the angle to C.
Mm-hmm.
When the angle is at C, now the opposite will it be 4,
Mm-hmm.
right? Hypotenuse
Yeah.
won't change. Hypotenuse won't change.
Mm-hmm.
And what about the values now? Can you tell me the new values?
3 divided by 5.
Okay. Look at all the values.
Yeah.
Now, supplementary angles. Now, this is another IGCSE concept, but many people forget it because it's a very low level concept. Now, you can say that it is a concept which comes in very primary level, but it's important here to get it back. Supplementary angles are those angles whose sum is 180. So, for example, here, X and Y are given in the line. So, X and Y is equal, sum of X and Y is 180. So what is supplementary angle? The angle whose sum is 180. Okay, now can you recall?
On a straight line, if there is an angle,
Hmm,
um, the angles sum up to 180. So x angle plus y angle equals to 180.
right. So now this is the property. Acha, give the heading in your notes, supplementary angles. Heading is necessary, so we have a record what topics we have done. Doesn't matter if we copy their material or not, but we should have a memory. Acha, now in this one, in this figure, you have to look at this angle. I show you the angle here. This total angle is 180. So this angle and this angle are supplementary angle. Look at the property. Sine ACB is equal to sine ACD. ACB is the interior angle and ACD is the exterior angle. For the cos, the property is the same. For the tan, the property is also the same. So the value comes back within 180. What it means, what's the meaning of this property? You need a calculator to understand this concept. I have sine 30. When I solve it on a calculator in degree mode, I get zero point 0.5. Achha, now if I subtract from 180, I get 150. and if I get the value of 150, I will get the same value. Now, this is called the property of supplementary angle. What is the property? If two angles are supplementary, if two angles are supplementary, their sine values are same. Now, do you have a calculator with you right now?
Yes.
Okay, can you check what is cos 50 and what is cos 30?
Okay. Cos 30 degrees is 0.8 and cos 150 is minus 0.86.
Hmm. Is it coming the same with a negative sign?
Yeah.
Good. Now, let's test our knowledge. This is called the property of sine, cos, and tan. Acha, what's the meaning of this property? Let me show you one more example. That let me say tan 30 and tan 150. Why 150? Because 180 minus 30 is 150.
Mm-hmm.
Now test it by using the calculator.
Yeah. 0.57
0.57. Good. And 150, tan 150.
minus 0.577.
Okay. The value is the same. The value is the same, but sign is negative.
Yeah.
Okay, good. So the property is decided. It means, let me give you a concept. When you make two angles like this, they are called supplementary angles. Supplementary angles are having the same value for sine, cos, and tan. But in case of cos, the value is negative also. In case of tan, the value is negative after getting a value. So whenever you get a sine value, it will be the same for the obtuse side also. Sine 30 and sine 150 are exactly the same. But cos 30 and cos 150 are opposite in sign. Do you remember
Mm-hmm.
the word acute?
Yeah.
90, and the word obtuse?
Yeah.
Less than 180 and greater than 90.
Mm-hmm.
So that angle is obtuse. Acha, when you take obtuse angle, sine is plus and cos is negative, while tan is also negative. Sine, cos, tan values are same. So whenever you get a sine value, it will be the same for the obtuse side also. Sine 30 and sine 150 are opposite in sign.
So your voice cut off, sir. Yeah,
Hello.
I cannot hear you. Oh, I can hear you now.
Sorry. There was a glitch, so I lost the connection. I hope you
Mm-hmm.
can see the screen. Um, Now, can you copy this screen in your notes, supplementary angles? The discussion was made, but then there was a little break. So you have to copy this.
Mm-hmm. Okay.
These are the rules which are called supplementary angle rules. Now, how these rules are appeared, how these rules have to be applied. Now, this is a triangle in which the ratio is 3, 4, and 5.
Mm-hmm.
This ratio is 3, 4, and 5. Acha, now you have to see the property. What would be sine ACD? You have to look at carefully that ACD, is it the exterior angle, this one?
Yeah.
Now we need to find the exterior, but as a property of supplementary, we know the values would be same. So because we cannot work out the exterior angle, we have to work out the interior angle. So if I come inside and here I'm standing on the question mark, what would be
Mm-hmm.
sine? This is opposite, this is adjacent, and this is hypotenuse. So
So
now
4/5.
hmm, for
Sine 4/5.
if I apply for this angle, let me say theta, what would be sine theta?
4/5. Sine 4/5.
4 upon,
5.
hmm, sine is opposite upon
Oh,
hypotenuse.
sorry, 3/5.
Very good. Acha, now if the sine theta for interior angle is 3 upon 5, this value, which is the exterior angle, will also be equal to 3 upon 5. Why it has the same value?
Mm-hmm.
Why it has the same value? Because
Um,
the two
they're
are
supplementary.
yes. Acha, now the same rule apply. How I can find cos ACD? What is the
Um,
theta for the interior angle?
cos ACB.
Hmm.
So they're
Cos,
supplementary.
cos is adjacent upon hypotenuse.
Mm-hmm.
So what would be cos theta?
Um,
Adjacent is
adjacent over hypotenuse.
will be
Adjacent over hypotenuse. So
uh,
4/5.
in number form 4 upon.
4/5.
Acha, if the interior angle cos is 4 upon 5, look at carefully here. The for the
Mm-hmm.
exterior angle, this one, it will be minus 4 upon 5. Why minus?
Okay.
Why minus?
Because it's the opposite.
Because in supplementary angles, cos remains the same. In supplementary angles, cos remains the same, but the plus becomes minus. Now, next one. Okay. Look at the third example, tan ACD. For the interior angle, what would be the, for the interior angle, what will be the tan theta? What is tan theta? Opposite upon adjacent. Can you hear me? Hello? Can you hear me?
Yeah, sorry, so my Wi-Fi just cut.
No problem. What is, can you repeat, please? What would be the tan theta opposite upon
Um,
opposite upon
opposite. Oh, 4/3. Oh, sorry, 3/4.
3 upon 4. Now come here, outside angle. It will be minus 3 upon 5. Same value, but negative.
Mm-hmm.
So now can you understand, for sine, value is the same. For cos, value is the same, but it is negative. For tan, value is the same, but it is negative.
Mm-hmm.
Look at this, sine 110 is equal to sine 70. Why? Because the sum of 70 and 110, see what is the sum of 70 and 110?
Is 180.
Yes. So the values will be the same. Look at this, sine 150 is equal to what?
And 30.
Yes. In this way, look at the property now. What is cos 110? Cos 110 is equal to minus cos 70. Why minus?
Because opposite supplementary.
Because in cos, the value is the same, but plus becomes minus. It is the second quadrant where cos becomes negative. Now, for obtuse angle, sine remain plus. For obtuse angle, cos becomes negative. For obtuse angle, tan is also negative. In the paper, if you forget, you can always look for the calculator. Calculator can confirm to you that are you using the right property or not. So now you have to copy this. You have to copy this screen.
Okay.
Okay. These are the examples. Look at these example. Value is the same. Value is the same, but the sign is plus and minus. Now give the heading complementary angles.
Okay.
The angles whose sum is 90 degree. These are called complementary angles. What are complementary angles? The angles whose sum is the angles whose sum is 90. So can you repeat the property? What are complementary angles?
The angles whose sum is 90 degrees.
Oh, the angles whose sum is 90 degree.
Mhm.
So what, now you have to copy this property.
Okay.
So the angles whose sum is 90 degree is called the angles whose sum is 90 degree is called complement.
Complement.
Acha, now the property, let us test our property, huh? 90
Mhm.
degree. That's how we test it. You need a calculator and you have to work out here. For example, I ask you to calculate sine 30 and then calculate cos 60. Now do this calculation.
Sin 30 is 0.5. Cos
Hmm.
60 is 0.5.
Sine 30 is 0.5 and cos 30 is also check
60.
cos 60.
Cos 60 is 0.5.
So can you see the values are same?
Mm-hmm.
Acha, now check the angles. 30 plus 60, how much is it?
90.
90 degree. Very good. So the value is the same. So the value is the same, but sum of angle is 90.
Mm-hmm.
Now I show you one more property, huh? Sine 10 degree and cos 80 degree. Check the properties.
Sin 10 degrees is 0.17. Cos 80 is also 0.17.
Now can you test the property? What is 80 plus 10?
90.
90. So what is the property?
Um, they both have the same values.
If two angles are complementary, if two angles are complementary, the sum of the angle is 90. The value of sine becomes equal to the value of cos.
Mm-hmm.
At complementary angle, sine value is equal to cos or the cos value is equal to sine. For example, now, can you imagine sine 45 degree will be equal to cos 45 degree? And why?
Mm-hmm.
Why cos 45 and sine 45 will be equal?
Yes,
No, why they will be equal?
because they add up to 90.
Yes. So now this is the property. So now you have to copy down the property.
Okay.
So what is the property?
Um,
If two angles sum to 180,
they all have the same value.
yes, sine 40 is equal to cos 50 and cos 40 is equal to
Sine
sine
50.
40. Copy this also example.
Okay.
So we are done. We have done this now. What is reflex angle?
More than 180.
Hmm. Angle between 180 and
360.
yes.
Okay.
So what is reflex angle?
An angle between 180 degrees and 360 degrees.
Now I hope you remember properly this Pythagoras theorem.
Yeah. Okay.
This is called Pythagoras theorem.
Mm-hmm.
Now apply this Pythagoras theorem. You can use a calculator if you want, or you can do it orally.
5 squared add 7 squared is the hypotenuse. So 25 at 49 is 7, no, 114.
114,
No, 74.
74.
Yeah.
Now, non-right angle triangle sine rule that was in our IG also. Please
Mhm.
copy this heading.
Okay.
Sine rule, look at that sine rule. A upon sine A is equal to B upon sine B is equal to C upon sine. Look at these arrows. In front
Mm-hmm.
of A, it is angle A. In front of B, it is angle B. In front of C, it is angle C. Now, do you remember
Mm-hmm.
how this rule was used to be applied?
Yeah, you take the value, substitute it, and then solve for the rearrange for the missing value.
Yes. Good. So now you have to look up this.
Mm-hmm.
Now you have to, can you solve it? This one?
Okay. Okay, answer is 35.
Answer is 35. Sure. Good. Ambiguous case of the sine rule. What was ambiguous case?
Um, I don't know.
Okay, so what is an ambiguous case? It's a special case when we are given two sides and the angle opposite of those given sides. It's a special case. When you solve it, you get an angle which is not looking to be correct. Suppose the side is very small and you're getting a big angle. This is a special case which is called ambiguous case. So this is a case when this type of situation come. There are two possibilities. One angle
Mm-hmm.
is 33. Look at the other option. Angle is 33, but the other
Yeah.
angle will change. Now, this is called ambiguous case. You have to memorize ambiguous case in the exam. How we identified the angle, one angle which we are getting is 180-degree different. So now look at these two triangles ABC. Angle A is 33 in this triangle. And if you go on the right side, angle A is also equal to 33-degree. But angle
Mm-hmm.
B is a problem. Angle B is not coming what it looks like maybe. Maybe it coming acute, but in real, it is obtuse. So after giving the heading, copy this theory.
Okay.
Okay. Now, this is called ambiguous case. And the ambiguous case in this one, you will apply the same formula, but the answer can come different. So now you have to copy this ambiguous case.
Okay.
Now give the cosine rule.
Mm-hmm.
What was cosine rule?
A squared equals b squared plus c squared minus 2b c cos a.
Hmm. This is another style for, this is another style for, this is another style for cosine rule. And now let's try a question. We use the same arrow method. The angle theta is facing the side 8. The angle theta is facing the side 8. Now copy this.
Okay.
So let's try quickly this option.
Mm-hmm.
Let me know once you get the answer.
So I got 1 over 7. Oh no. Wait. So I got 81. 0.78.
It comes to be 82 overall.
Yeah.
So, so we are done with sine rule, cosine rule, and this topic is not completed yet, but
Mm-hmm.
we will inshallah continue it in our next class. You should try to do some questions from the homework. I mean that
Okay.
we have two topics done, coordinate.
Okay.
Okay.
Yeah.
Topic will inshallah continue in our next class.
Allah Hafiz.
Allah Hafiz.